The single shaft crusher is widely used to crush thick materials, such as heavy wood, large pieces of plastic, rubber, tires, composite materials, etc., and can also crush various types of wood, paper, electrical cables, chemical fiber materials, industrial waste, etc. This single shaft crusher can be equipped with springs and knobs with different extras for effective rotor positioning and cutting. To achieve the effect of fine crushing of materials, intelligent induction, pressure balance, avoid jams, high output, and strong material adaptability. How does it work? As the professional shredder manufacturer, let's analyze its working principle. The multifunction shredder is also called rough breaking, which uses cutting, tearing, and squeezing between knives. The principle processes metal materials and is used for the crushing of various solids. Waste. It is often used in environmental protection, fields such as municipal solid waste disposal. Bulking. According to the movement mode of the forging, die forging can be divided into swing rolling, swing swivel forging, roll forging, cross wedge rolling, ring rolling and cross rolling, pendulum rolling, pendulum rotary forging and ring rolling. Can also be processed by precision forging. In order to improve the utilization rate of materials, roll forging and cross rolling can be used. As the pre-process processing of slender materials, rotary forging, like free forging, is also partially formed. Its advantage is that it can be formed even when the forging force is smaller compared with the Z of the forging. In this forging method, including free forging, the material expands from the vicinity of the die surface to the free surface during processing. Therefore, it is difficult to ensure accuracy. Therefore, the movement direction of the forging die and the swaging process can be controlled by a computer. The forging force of the company can obtain products with complex shapes and high precision, such as forgings such as steam turbine blades, with a variety of production and large sizes. Principle of constant volume. When forging each type of forging, a forging worker must first calculate the material and cut the material according to the weight and fire consumption of the forging. The basic formula for calculating the material, G 等于 the weight of the blank roll, the specific GR of the material with the volume of the blank. When calculating the material, the volume of the raw material must be calculated due to the different specific gravity of value as raw materials, and then multiplied by the specific gravity to obtain the forging the weight of them. While forging is closely related to the volume before and after forging. During forging, such as pier thickening, lengthening, punching, mandrel lengthening, shoulder pressing, shifting, bending, intorsion, its overall volume remains unchanged, while its shape is changing, such as from a circle to a square, from a square to a circle, from an octagon to a circle, etc. But the volume remains the same. The principle of stress and elasticity is mainly used with forged workpieces, heating and cooling heat treatment, the formulation of the margin of the forging of the workpiece, the final forging temperature of the workpiece after forging and the material of the workpiece, and the shrinkage force is not equal. The internal stress of the workpiece is determined. The cooling system and heat treatment specifications after breaking. This principle is very important. Stress includes temperature stress, thermal stress, structural stress, residual stress. When processing large forgings, the larger the rectangular section and the circular section, the thermal stress, and the residual stress generated are particularly prominent. When billet is heated, the greater the temperature difference between the inside and the outside, the greater the thermal stress generated. Therefore, when heating large forging blanks, the temperature must be fully and uniformly heated, and the temperature must be strictly controlled. Strain stress, forging and pressing of the workpieces, mainly to break the S-cast structure and refine the gray, NS. When the deformation reaches a certain degree, the S-cast, coarse and dendritic crystals and grain, boundary materials are crushed. The workpiece is deformed and yielded, closed, compacted, welded, and compacted after reasonable forging. The compactness, continuity, and mechanical properties of the workpiece can be significantly improved, but the workpiece will produce its own structural deformation stress during forging. When the pressure is extremely high, the deformation stress that occurs is extremely strong, such as 9C no-cold rod. Rolls are particularly outstanding in heat treatment after heating and forging. Forging production is carried out in the state of metal burning, for example, low carbon steel forging temperature range between 1250 to 750. Due to a lot of manual labor, burns may occur if you are not careful. The heating furnace in the forging workshop and the hot steel ingots, blanks and forgings continuously emit a large amount of radiant heat. The forging steel have a relatively high temperature when the forging is finished, and workers are often exposed to heat radiation. 3. The smoke and dust generated during the combustion process of the heating furnace in the forging workshop is discharged into the air of the workshop, which not only affects the health, but also reduces the visibility in the workshop. The situation is more serious for the heating furnace burning solid fuel, so it may also be cause an accident at work. 4. The equipment used in forging production, such as air hammers, steam hammers, friction presses, etc., all produce impact when the work. When the equipment is subjected to such an impact load, it is prone to sudden damage, such as the sudden breaking of the piston rod of a forging hammer, which may cause serious injury. Presses, such as hydraulic presses, crank hot rod forging presses, flat forging machines, precision presses, shoring machines, etc. While working, although the impact is relatively small, sudden damage to the equipment also occurs from time to time. The operator often caught off guard. It may also cause work-related accidents. 5. The force of forging equipment in work is very large. Forging equipment such as crank presses, stretch forging presses and hydraulic presses, although their working conditions are relatively stable, the force generated by their working parts is very large. For example, my country has manufactured and used a ER-010T forging hydraulic press. It is a common press of 100-150T, and the force it emits is large enough. If the mold installation or operation is slightly incorrect, most of the force will not act on the workpiece, but on the mold, to all parts of the equipment itself. In this way, a certain installation and adjustment error, or improper operation may cause damage to the mech, hand parts and other serious equipment or personal accidents. 6. Blacksmith tools and auxiliary tools, especially hand forging and free forging tools, clamps, etc., have many names, and these tools are all placed together at the work site. During work, tools are replaced very frequently and storage is also messy, which will inevitably increase the difficulty of checking these tools when a tool is needed in forging and cannot be found quickly. Sometimes it will be mid-dual use. Similar tools often cause work-related accidents. For this reason, due to the noise and vibration during the operation of the equipment in the forging workshop, the work site is noisy, affecting the human hearing and nervous system, destructive, and increasing the possibility of accidents. Process that advanced manufacturers have generally adopted thermal processing computer simulate in technology, computer-aided process design in virtual technology to improve the level of process design and adapt the manufacturing capabilities. Introduce and apply simulation programs such as Datefur, Simac AutoForge before, large-strand shape, and thermocoat to realize computer design and process control of thermal processing. Our forging technology CMM and above hydraulic presses are mostly equipped WITH-E-40-T and main forging operations the machine AN DR-0-40T of serial manipulators. A considerable number of manipulators are controlled by computer, which realizes the comprehensive control of the forging process of the forgings, so that the forging accuracy can be controlled. 微并加减3毫米 and the online measurement of the forgings adopts the laser size measuring device. 3. Heat treatment technology focuses on improving product quality, improving heat treatment efficiency, saving energy, and protecting the environment. For example, the computer is used to control the heating process of the heating furnace and the heat treatment furnace, and the burner is controlled to realize automatic adjustment of combustion, adjustment of furnace temperature, automatic ignition and heating parameter management, waste heat utilization. Heat treatment furnace equipped with regenerative combustion chamber, etc. effectively control the cooling of the polymer quenching oil tank, and various water-based quenching media gradually replace the traditional quenching oil. 4. The proportion of CNC machine tools in the machining technology industry is gradually increasing, and some companies in the industry have machining centers and are equipped with proprietary processing machinery according to different types of products, such as 5-axis machining centers, blade processing machines, roll mills, railways, etc. 5. Quality assurance measures. Some domestic enterprises have been equipped with the latest detect, eye instruments and testing technologies, modern automated ultrasonic flow detection systems using computer-controlled data processing, various dedicated automatic ultrasonic flow detection systems, and various quality system certifications, etc. The key product